Now, the text talks about importance and kind of how do you determine which models are best, which approaches are best at determining the relative importance of variables. And the book makes the case of simultaneous is a better approach for determining the importance of a variable. I'm in the camp, that's not a universal perspective. I'm personally in the camp that you should avoid talking about the importance of one variable relative to the other variable. That is not a statistical question. That can't be answered by statistical analysis. That's where I disagree a little bit with the book. I don't think importance is a theoretical question. Importance isn't you can't test, there's not a statistical test for importance. And here's why I would stake that position. I mean, you think of simultaneous multiple regression ignores the causal sequence. It's ignoring the fact that mom's education has an effect on all those other variables that might be fairly big. You can end up, it only focuses on that unique, direct effect that the variable has. And simultaneous, completely doesn't pay any attention to the indirect effects that a variable may be having. You can have a small direct effect, but actually for a variable that actually has a very large effect through indirect pathways. Think for example, I'm looking at teacher training. I'm doing an intervention, maybe, looking at teacher training, predicting classroom practice and educational outcomes. And I think I'm teaching teachers certain skills. It's going to improve their classroom practice. What those practices are unimportant. But training leads to better classroom practice. Better classroom practice leads to better educational outcomes. Training may also have a direct effect on educational outcomes through either directly, somehow it just makes the teachers better, or there's maybe other variables out here. Remember, the direct effect sucks in any other indirect effects for variables that aren't in our model. Maybe it leads to teachers being nicer to kids, which leads to better academic outcomes, and there's an indirect pathway there. All those other possible explanations are part of the direct effect. It's the effect that the variable has uniquely on the variable, including through other variables that we just don't have data on. So anyway, this is a model. Makes a lot of sense. Teacher training leads to better classroom practice, leads to better educational outcomes. Now, the total effect of teacher training might be very large. And it might be very large due to the indirect effect of classroom practice. I'm training teachers to do something. Teachers then do whatever that is, and they go on to have better educational outcomes in their students. This could be a very large effect, completely completely due to teacher training. The direct effect of my intervention may be very small. And this should not be surprising. Because keep in mind, my intervention is telling teachers, do this. There may not be much of an effect. That may have a very big effect. If teachers do this, it may have a very big effect. But the effect, if my intervention's focused on this, other direct effects may be very small. That's not surprising. This is what's called, we've talked about this as kind of a mediator. This is a mediational relationship. A leads to B, B leads to C. This is our mediator. And people will talk about something like this as almost complete. If there's a little small direct effect, it'd be almost complete. A complete or total, or you may say complete, total, or full mediation would be there's no direct effect. It's all indirect. And that can happen with a targeted intervention. Well, if we did that in simultaneous multiple regression, so here's that same data kind of visually with a simultaneous regression where we're not entering things sequentially. So we're just saying, these two variables are correlated. I really don't care which one's causing which one. I'm just going to look at I want to evaluate how important the variable is by looking at their unique effect. You run the risk that classroom practice looks like it has a very large effect. And maybe teacher training, because the effect, and maybe teacher training controlling for classroom practice has a very small effect. You're going to walk away and say, teacher training, your intervention had no effect. It's not important because it had a small direct effect. And you've completely missed how it's actually having its impact. I wouldn't want to look at this and draw the conclusion. If you kind of follow that logic tightly, you look at this and draw the conclusion, training's not important. It all just comes down to what's happening in the classroom. The training isn't having any effect. Now, in defense, I'm sure you present this to researchers who take that position, that simultaneous regression is how you determine which variable is more important. And they would look at this and say, well, yes, but of course. We all know you don't do it this way if you think that there's this sort of mediational model. There's all sorts of rules and things on how you test those mediational models. You would never draw this conclusion because you wouldn't do a simultaneous regression when you think this is going on. To which my response would be, yeah. So why are you saying then this is how you judge if something is important when you're saying, well, but not always, or, well, it kind of depends if it's, no. Avoid thinking importance is not a statistical test. You notice if you pay attention to the book, regularly, I didn't appreciate, I think it might be more in this text, this version, which I like. He references Pedizer a lot, which is kind of, Pedizer's more of a purist, which I used to use his book. Anyway, so I'm in the camp. You don't try to make the argument that something's important. It's not that simple. And you might think, well, then maybe sequential is the way to determine something's important. If I've convinced you that simultaneous isn't the way to determine importance, because look, sequential is the better way looking at those mediational effects. But the problem with sequential is that each of those effects are different based on the order that we put them in. When we put in mother's education first, the total effect of mother's education is the R squared for mother's education. Then when we enter school quality, the total effect of school quality isn't the R squared anymore. It's the partial R squared after it's our semi-partial squared, after we've removed the effect of mother's education. We look at the effect of studying, it's the R squared for studying after we've removed mother's education and after we've removed school quality. Each variable, we're not comparing apples and oranges. We are comparing apples and oranges now. They're different measures of effect at each step along the way. One's an R squared, one's an R squared controlling for something, one's an R squared controlling for something and something else. And the more variables you have, the more something else is you're controlling for. So to look at one and say this is a big effect, that's not, well, it's like looking at, an orange is more orange than an apple. No. They're different things. Kind of spell it out here a little bit. So again, theory tells you. Your interpretation, theory, and your interpretation of the results. You need to make the case of this is an important effect or not. Don't just look at some, as much as I love the numbers, don't just look at a number and a p-value and a t-test and say, oh, that's important. Okay? Two other things we want to talk about before we move on. One is straightforward, the other is a little bit more. We'll start with the one that's straightforward. Adjusted R squared. When you look at the outputs, you'll notice there's like the little column of there's your R squared, then there's an adjusted R squared, and there's the R. And we haven't talked about the adjusted R squared yet. Remember, when we're looking at R squared, the R squared in multiple regression, because we're looking at, remember, the R in multiple regression can only go from 0 to 1. It can't be negative because we've got more than one variable. And R squared in multiple, well, in both multiple and in simple regression, we can calculate R without looking, there's ways you can calculate R to get around the sum of squares divided by the regression sum of squares divided by the total sum of squares. In multiple regression, our R squared is the regression sum of squares divided by the total sum of squares because it's two squared numbers. R squared is always positive. Well, think about it. R squared. Right there, it tells you it has to be positive. There is no negative. And if you think, well, what if you take the square root? You can have a correlation of negative 0.8 and square it and get an R squared of lowercase r squared of 0.64, but you can't do that in multiple regression. In multiple regression, you can take the square root of your R squared, but it's always going to be a positive number. Because it's always positive, it can't go negative. It is biased to be a little more positive. It's biased to be a little too big. You think about it another way of thinking about it as well as, remember, as we noted, as we added variables into the regression model, your regression sum of squares can only go up. Well, it can stay the same or go up. It can never go down because even adding a completely useless predictor doesn't take away the amount of variance that the other variables already accounted for. So again, because it can't get smaller, it tends to be, any error is kind of tilted towards making things bigger rather than making things smaller. So your R squared is actually a slightly inflated estimate of what the true R squared in the population would be. It's a little inflated, and you can adjust for it using this formula, which is kind of messy. 1 minus R squared times n minus 1 divided by n minus k minus 1. And what you can see kind of right here is, in the end, if n is really, really big, R squared and adjusted R squared are almost the same. Now, you may see people debate. Well, you'll completely appropriately so, you'll see people talk about we should be reporting R squared, not R squared. We should be reporting the adjusted R squared, not R squared. The trick with that is this does not mathematically work out as clean. We're going to see, notice how when we're doing those Venn diagrams and you add up each of them along the way, they all add up to the total. Stuff like that doesn't work with the adjusted R squared. So it's not as mathematically straightforward or as mathematically tractable as the regular R squared that we're really going to focus on. But you'll see it. I just wanted to put it out there so you're aware of it, that what it is and why you see it on every computer software just about is going to give you the adjusted R squared as well. And you may wonder, why is it that no one ever talks about it? Well, because typically the difference is so small, it's just easier to stick with the R squared. Okay? One other thing, now this takes a little bit more.